Hello everyone, my name is Sonu Yadav
My name is Logan.
My name is Samir.
and we are Firestarters. For this project, I worked on the front end and the data cleaning.
I worked on the data cleaning and the model orchestration.
I also work on data cleaning and RAG.
Awesome. Let me take you through our user interface. So to start out, we're looking at the port of Houston right now. We can zoom in and out to give us a broader view of what we're dealing with here. All of these arrows signify a ship being tracked by AIS. So as I zoom out, we're tracking 18 vessels. As I zoom in closer into the port, we're going to be tracking less because we can only see so many. This data is refreshed every 30 seconds. And all of the lines here signify specific networks. Do you want to take us through some of that, Samir?
Yeah, sure. So if we look at this map control, we can toggle specific overlays. So if we click on the show rain overlay, there's not much rain going on here in Houston, but you can toggle these different overlays. So the rail lines, you can also have, so the rail lines here you can see in yellow. You can see the rail nodes. If you zoom in a little bit, you can see the purple rail nodes, and then you can see specific rail networks like UP, BNSF, and other railroads.
Awesome. So down here, we've got our AI search and retrieval functions. So this is what's providing our interface for our RAG. All of the data within our data sets is being called upon using OLAMA here. And so here we can ask, what is the surge risk of the amount of ships being in the port right now, and this will give us feedback on, right now we are currently at a low risk, which is great. I mean, it's super late at night, so we'd hope it'd be low. But ports are busy, so you never know. Over here, we've got our ship tracker. So as ships show up within AIS on our scope, we will add that into a metadata file. And so the longer that this program runs, the longer we'll be able to see more ships come in, more ships, end up being docked, more ships departing. Super exciting and super easy.
And over here, we have 72-hour ship forecast. Where we are tracking ships every 72 hours. In the last 72 hours, we have had 35 ships, and we used math to calculate the number of ships we have in the duration window.
Awesome. And lastly, we've got a really cool dark and light mode toggle right there.
Yeah, I also wanted to mention one more thing. So this is all running locally on our NVIDIA DGX Spark. So if you try and give it one more prompt here, you can see our GPU spiking up right over there.
So there we go. This is our lovely NV top. Super great for observing your GPU under workloads,
And the Asus SNGX10, which is very difficult to find, but AITX and the organizers here made this available to us.
Thank you, guys. We're going to explain to you what we did to make our project.
So for this project, we leveraged 6 critical data sets to build a comprehensive supply chain port tracker. We integrated real-time data sets, which includes vessel movements, cargo manifests, and berth utilization across major container ports.
And so the frameworks that we used, the first one was LangChain. We also used ChromaDB as our vector database for RAG, and then we used Pandas to process our CSV files and then put it into ChromaDB. We used sentence transformers as well as OLAMA. Our model was Qwen 2.5 30 billion parameters.
So this is the setup that we use for our RAG flow. Thank you, NVIDIA. As Samir explained, we've got our vectorized data that we need to actually vectorize. So all of the training data, all the data sets gets forwarded through. Thank you, transformers, gets added to our vector database, and then anytime somebody wants to talk to the user interface to actually talk to the data that we've fine-tuned, that's how this flow works. So we've created the front end, which is a really, really simple HTML file, and then running behind that, we've got our server.py file, which is doing all of the orchestration for all the data. A lot of the data is going to be coming through ArcGIS for AIS, We've got a lot of data coming for the vessel data that we're adding, and then all of that gets positioned into the map or the front end that we're running. That's running in Python as well.
And this is our project, and we would again like to thank the organizers for bringing us this resume.
Thank you very much.
Thank you.